In this video, we're going to be finding the maximum bending moment in a simply supported beam. In this example, we're drawing a shear force diagram and bending moment diagram for a simply supported beam with point loads. So the first step is to find the support reactions. So we identify what type of supports we have. At A, we have a pin joint. This is going to allow rotation, but it prevents movement in both the X and the Y directions, giving us support reactions AX and AY. B is a roller, so it allows rotation. It also allows movement in the X direction, so it only has a support reaction BY. So when we take the sum of the forces in the X direction equals 0, we only have the AX is equal to 0. Taking that the sum of the moments at A is equal to 0. So we take moments counterclockwise as positive and clockwise moments as negative. For the counterclockwise moments, if A is fixed, the only force that would turn the beam counterclockwise is the BY. So for positive moments, we have BY multiplied by 6, because moments is force multiplied by perpendicular distance, and B is 6 meters from A. Next, we take our clockwise moments, which are negative. So we have the 30 kilonewton force. So this is 1.5 meters horizontal distance from A. So we get minus 30 times 1.5. And finally, we also have the 10 kilonewton force, which would also turn it in a clockwise direction. This is 4.5 meters from A. So we have minus 10 times 4.5. And these all add up to 0. Rearranging and solving, we get that BY is equal to 15 kilonewtons. Then we can take our third equilibrium equation, the sum of the forces in the Y direction equals 0. So taking up as positive and the downward direction as negative, starting at the left-hand side this time. So we have our support reaction AY. This is positive, so we add it on. Then for the 30, it's down, so it's minus 30. The 10 kilonewtons, this is also downwards, so it's minus 10. And then our support reaction at B is 15, which is upwards, so it's plus 15. And these add up to 0. Rearranging and solving, we get that AY is equal to 25 kilonewtons. And now we can draw our shear force diagram. So with the diagram, we start on the left-hand side at 0, and we only make a change where we have a force on the beam. So we start on the left-hand side at A. We have 25 kilonewtons upwards for our support reaction at A. So with the shear force diagram, we go up by 25, and then we go across, and we don't make a change until we get to the next force. So the next force is 30 downwards, so we go down by 30. So 25 minus 30 is minus 5. And again, we carry across at the same level until we get to the next force. So the next force is the 10, which is also down, so we have to take that off. So minus 5 minus 10, we come down to minus 15. Again, we go across until we get to the next force. And the last force is the support reaction at B, which is 15 upwards. So we have to add 15, which brings us back to 0. So the shear force diagram should always start and end at 0 if the beam is at equilibrium. And then from the shear force diagram, we can draw the bending moment diagram. So again, we start at the left-hand side at 0 at A. So we have a constant shear force, so we're going to get a straight line for the bending moments. So to work out the bending moments at that 1.5 meter point where we have the 30 kilonewton load, we want to take the area under the shear force diagram. So this area is 25 kilonewtons multiplied by 1.5 meters, which is 37.5 kilonewton meters. So at the 1.5 point, we have 37.5 kilonewton meters. So as we have constant shear force, we're going to have a straight line for the bending moments. So we can draw a straight line from the 0 to the 37.5. So the next point that we can work out for our bending moments is going to be at the 10 kilonewton load. So we want to work out at that 4.5 meter mark how much we're going to reduce the bending moments by. So we have a shear force of -5 for 3 meters. So -5 times 3 is -15. So we need to subtract 15 kilonewton meters from that 37.5, which brings us to 22.5 kilonewton meters. And finally, for the last section, we have a gradient of -15 for our line. So to work out where it ends at B, we do the same thing again, so work out the area of the graph. So we have -15 multiplied by the 1.5 meters. So the area is -22.5. So we take that off of the existing 22.5, and this will bring us back to 0. So we do a straight line connecting the 22.5 to the 0, and this is where the diagram ends. So from here we can read off the maximum bending moments, and this occurs at the 1.5 meter mark where the 30 kilonewton force is, with a maximum bending moment of 37.5 kilonewton meters.